Hi kids! Welcome again to The Amazing Race. We have already discussed about energy transformation on the first module. Now, for the second part of the series, we're going to learn about force. Let us start!
Here now is your most awaited event, the race of the century. This is the Amazing Race. Behind me, you can see the participants with their specialized cars. For the first competitors, let's ask Phineas and Ferb about their car.
There's 104 days of summer vacation, and school comes along just to end it. So the annual problem for our generation is finding a good way to spend it.
I'm Phineas.
And I'm Ferb.
And we're proud to present to you our invention, our out-of-this-world car, the Flynn Fletcher hovercraft. You see here, unlike other cars, ours can move even without wheels. We're sure we're going to win this competition.
Wow, a hovercraft! Will Phineas and Ferb win this competition? We will see later. Let us move to another competitor's car. Bello, 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 Banana, Gelato, Gelato, Stuart, Kevin, Bob, Stuart, Bapoy, Bob, Bob, Banana! Bello, 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 Bello. Okay, so this banana train can change its direction. It can go in one straight line as well as with its banana carts parallel with each other. So, why did you guys design your train like this? Bello, 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 Bello. Okay, that's enough, guys. We should move to the last competitor, the famous SpongeBob SquarePants.
Who lives in a pineapple under the sea?
SpongeBob SquarePants!
Absorbent and yellow.
Hello, everyone. Da da. What can you say about your car? I love my car. And I love Krabby Patty, so I made a Krabby Patty car. So, what is so special about your car? Well, I love my car. Never mind. Kids, we are so lucky because for the very first time, we are going to witness the first ever race between the three characters you all love. But before that, we will let our competitors to test their cars in a test drive. Are you all excited? Now, kids, look at the hovercraft. It slowly speeds forward and upward. This is an example of Newton's second law of motion, the law of acceleration. In a car, the machineries generate the necessary energy to move. It causes an invisible external force to push the car forward or backward. When an object speeds up, slows down, or changes direction, then there must be an external force acting on it. This is the essence of the law of acceleration.
Look, Ferb, our hovercraft is a success. We're going up.
And still going up.
Yes, I think this should not be happening. We should have stopped going upwards after a couple of feet and should have just moved forward and not upward. Oh well.
The banana train seems fine, and the minions look like they're having fun. Well then, let's check out how SpongeBob is doing. It seems like SpongeBob has not improved his driving skills at all. I wonder what Mrs. Puff will say about this. You see, kids, how SpongeBob moves forward when the car stops and how he moves backward when the car starts. This behavior of an object abruptly stopping, then starting again, can be explained by the law of inertia.
The law of inertia explains that an object at rest will remain at rest. If in motion, it will move at a constant speed in a straight line, unless it is acted on by an unbalanced external force. As explained, every person possesses a certain property that causes a body to resist changes in its state of motion. Newton called this inertia.
Oh no! It looks like there's trouble! Whoa! Stop! 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 Kids, this banana train is amazing. Instead of being damaged because of the crash, it moves like a pendulum. This pendulum action demonstrates the third law of motion, or the law of interaction. It states that for every action, there is always an equal opposite reaction, or the mutual actions of two bodies upon each other are always equal and directed to contrary parts. The third law of motion means that in an action, there is always an opposing reaction. As we can see in the banana train, the first cart bumped the second cart, then the second cart bumped the third cart. And because there is always an opposing reaction, there is a tendency for the third cart to bump the second cart back, and so on and so forth. Hence, the pendulum.
At last, Ferb, we are currently going down. Too fast.
These cars are really amazing. The hovercraft should be crushed by now, but because of the hovercraft's special ability, it is now bouncing like a ball. Bouncing is another example of law of interaction. Again, we can see that the hovercraft crashed on the racetrack, thus exerting force. And because there is always an opposing reaction, the racetrack also exerted force towards the hovercraft, making it bounce. Whoa! When forces acting on an object are not balanced, motion takes place in the direction of the greater force. When balanced, there is no motion. Just like how SpongeBob, the force was not balanced when SpongeBob lost control and went down the hill.
Remember, in the law of inertia, an object will continue to move in a straight line unless an unbalanced external force acts upon it. In this situation, the tangle of banana train and hovercraft became the unbalanced external force that stopped the Krabby Patty car. The two cars combined were much heavier than the Krabby Patty car. The difference in mass resulted to unbalanced forces.
Oh no! Our cars are tangled and the race will start in 5 hours. What should we do?
We should start fixing our cars.
Poka, 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 ba.
3 hours later.
While our competitors are fixing their cars, why don't we talk about force in general?
We've been saying force quite a lot for a while now, but what really is force? Force is when you see a change in the motion of an object, making an object move, speeding it up, slowing it down, or simply changing its direction are effects of force. Force is everywhere. We cannot see it, but we can observe its effects. For example, the hammering of a nail, or pulling of a cart, or even the simple bending of a body, force is in there. But an object not in motion does not mean there is no force acting upon it. It is at rest because the forces are balanced. Just look at SpongeBob. He is so tired that he cannot help but just lie down. He is not moving from his spot. This means that SpongeBob and the earth he's lying on are giving off balance forces. When an object is not in motion, it means that the forces are balanced. Thus, the object stays at rest until an unbalanced force acts upon it.
2 hours later.
Now that everyone's cars are fixed and ready to go, let's start our race! Welcome to the Amazing Race!